of illumination. Okay. So basic definitions were discussed about, suppose you know that solid angle, then uh, then we are discussing about luminous flux, luminous intensity. Okay, then candle power, then different factors, reduction factor, then illuminance. Okay, illuminance and luminance. Okay, both we have discussed. Then luminous luminous excitance, transmittance. Okay, then reflection ratio or coefficient of reflections or reflectance, everything we have discussed. Okay, now today we are discussing about specific output or the efficiency. Okay, so efficiency, from you know that from the very basic definitions. Okay, so input, the ratio between your the ratio between your output over the input in 100%. Okay, so how much error is there? Okay, sorry, how much losses are there? Okay, so that is normally coming under your input equal to output plus losses actually. Okay, so based on that you are getting over here, so different efficiency. The lamp, the ratio is luminous flux, okay, of the power intake, how much power intakes are there. Its unit is your lumen per hour watt. Okay, lumen per hour watt. Okay, so lumen, you know that for what, how much value, that formula directly it is given, the relationship. Okay, already given that MSCP 4 pi into MSCP whole divided by watt. Okay, or LM by watt equal to, you can write down like that, 4 pi by watt divided by MSCP. Your MSCP means it's the ratio between MSCP and MHCP. Okay, so directly you can get the formulas. Okay, so from different steps. Okay, some basic formulas are given over here. Okay, so when we are doing the numericals, based on that formulas we have to calculate that value. Okay, so today some numerical I am going to discuss. Okay, so it's defined. So another one is the specific consumptions. Okay, what is the specific consumptions? It is defined as, okay, it is defined as the ratio of the power input to the average candle. So ratio between power input to the average candle power. Okay, so it is expressed in terms of watt per average candle or watt per MSC. Okay, by that way you can find out that value. Okay, so next one is that next one is what? Next one is your next one is what are the basic the tables are there. Okay, what are the basic components, name of the quantity and their unit and their symbols, how we are getting. So luminous flux. Okay, luminous flux, it is your unit is lumen. Okay, you can say like that, A for 5. That luminous intensity, or it is also known as candle power. Okay, unit is candela. Okay, so you can say like that, it is I. Okay, illuminance. Okay, illuminations or illuminance. It is your lumen per meter square or the lux. Okay, this is known as symbol is E. Okay, illuminance. Now it is luminance or brightness. It is candle per meter square. Okay, means candela per meter square means luminous intensity whole divided by area. It is known as L or B. Okay, and that luminous excitance, this is lumen per meter square, or you can say also like that it is m. Okay, these are the basic symbols how we are find out. Okay, so symbols and their units. Okay, now most important thing, that is your laws of illuminations. Okay, laws of illuminations or illuminants. Okay, so what was that laws? First one, that E is directly proportional to the luminous intensity I, so of the source, E directly proportional to the I. So what is E? E is your illuminations or illuminants. Okay, so it is your illuminations of the surface depends upon the following factors. Okay, what are the following factors? Based on that you are defining the law. The source is assumed to the point source. Assumptions are important. This is your point source, and the otherwise the sufficiently away from the surface regard as such. So how much away from your surface, that also important factor. Okay, so now first formula is that what E is directly proportional to the luminous intensity or I of the source, E directly proportional to I. Number two is that what? Inverse square law. Okay, what is the inverse square law? The illumination, okay, the illuminations of a surface is inversely proportional to the square, inversely proportional to the square of the distance, the surface of the source. Okay, so you can directly say like that, E directly proportional to 1 by r square. Okay, it is simple. Okay, so the illumination of the surface is inversely proportional to the square of the distance the surface from the point source. Okay, so E directly proportional to 1 by r square. Now some figures are there. Okay, that figures you know that is source. Okay, this is your source. Now radius are considering r or x, 2x, then 3x. Okay, so it is your source. Then these all are the area. Okay, these areas are there, areas. Okay, all the areas are there. Okay, now it is your f. F means what, you say like that, flux. Okay, luminous flux equal to f. So if it is your now angle is there. Okay, so theta angle, now it has been changed. Okay, so in figure, so from the figure it is shown that portions of the surface, three sphere. Okay, so this is part of your one sphere, second sphere, and this is your third sphere. Three spheres are there, only radius are different. Okay, whose radii are in the ratio is 1:2:3. So radius are different. All these portions, okay, obviously is sustain the same solid angle at the source. Okay, same solid angle. Okay, the source, and hence receive the same amount of total flux. Okay, same amount of total flux. However, since their area are not, their area are in the ratio of 1:4:9. Okay, basically 1 by r square. So you can make it square. Okay, 1:2:3. Directly it is coming. Okay, so 1 by r square. So 1:1/4:1/9. Okay, direct illumination ratio are there. Okay, I am writing like that way. Okay, now next one is that Lambda cosine law. Okay, that area. Okay, so area is there A. Now it is position 1. Now position 2. Okay, now theta angle is there. According to this law, E is directly proportional to the cosine of the angle made by the normal illuminated surface of the direction of the incident flux. Okay, just for a moment. So here you can see that incident, here you can see that a angle made by the normal, the illuminated surface with the direction of the incident flux. So you have that incident flux F. Okay, so is directly proportional to the cosine of that angle made by the normal of the illuminated surface. So if it is A illuminated surface, so now it is angle will be there. Okay, so A cos theta. Okay, now it has been changes to that one. So what will be the formula? So here it is your different position. It is A, B, C, D. 4 positions are there. Angles are changing. This is theta 1. Okay. Theta 1. Now this one theta 2, theta T, theta 3. 3 angles are there. So it is shown like that in the figure. Let theta will be the flux incident on the surface of area A. Okay. Flux in the surface of area A when the position 1. When the surface is turned back through that angle theta. Okay, so turn back angle theta. Okay, the flux incident, it will be as per the formula phi cos theta. So definitely if total flux will be there, so now it is changing to that angle. So definitely theta has been changed. So phi cos theta. Hence illuminations of the surface, it is E1 equal to phi by A. So you know that what will be then E2 phi cos theta by A. Normally you know that phi, okay, phi by A, but in position 2 what will be there, it will be changed now. So phi cos theta as per this angle, phi cos theta by A. And now what is the relation between E2 illumination 1 plus and illumination 2? So E2 will be like that. Okay, so phi by A equal to what? E1. So E2 equal to E1 cos phi. Okay, E2 equal to E1 cos phi. Now you know that combining the entire thing with that distance. So what will be the total thing? So E will be there, total E equal to I cos phi by R square. Okay, so from that beginning, okay, that beginning the formula was there. From there you are writing like that. E equal to I cos phi whole divided by R square. Okay, the unit is Lm by meter square. Okay. EA means A position, it is directly coming like that, I by H square. Okay, I by H square. Since theta tends to 0, so cos theta equals to 1. Theta is for almost perpendicular. Here you can see. So this theta 1 goes to 0, more or less. Okay, so theta goes to, so cos 0 equals to 1. So that's why I by H square directly it is coming. Okay, so you are considering that height equal to, instead of R you are writing H. Okay, so I by H square. So now what happened for EB position? Okay, EB positions, it will be like that. Direct formula you are using. EB equal to I by LB square. Okay, L is that lamp position, that LB. Okay, LB square. Okay, that length LB square. Okay, this one. This is your LB. Okay, LB square into cos theta 1. Okay, that simple one. That R1 equals to what? Distance. Okay, distance equals to, now it is LB. Okay, LB square will be there into cos theta 1, that angle of theta 1. Okay, I by LB square into theta 1. Okay, I by LB square into theta 1. That will be your EB. Since cos theta 1 equal to what? Cos theta B by H. Okay, B by H for this one. B equal to what? H. Okay, and hypotenuse is B, is your LB. Okay, so you can replace this cos theta 1 H by LB. You are replacing that cos theta H by LB. Now what will be that value? I into H by LB. Okay, so directly you are replacing that value LBQ actually. Okay, this is the LBQ. Some printing mistake is there, so it will be LBQ. Okay, multiply with LB square. So what will be that value? You can also write down I by H square into H cube. Okay, so it is your I by H square into H cube. Directly you can write I by H square into H by LB whole cube. That is your EB. Okay, I think you are able to understand EB. So I by H square equal to EA. You know that value is I by H square equal to EA. From here you are writing. So it is coming what? EB equal to EA into H by LB whole cube. Okay. So H by LB whole cube equal to cos cube theta 1. Okay, so again H by LB means this one. cos theta 1 equal to h by L. So directly cos theta 1. Okay. So what is their formula? Directly EB equal to EA cos cube theta 1. Okay. I hope you are able to understand. So same thing for EC. For EC, for this point illumination C. Okay. At that point EC equal to EA cos cube theta 2. Cos cube theta 2. So you do that, how it is coming, that proof you can do in your home. Okay, sorry, you can solve it how that two things are coming. EC equal to EA into cos cube theta 2 and ED equal to EA cos cube theta 3. Okay, that two expression you will do that in your homework copy. Okay, how do you get it directly? Okay, so that proof are very important. Okay, so at the time of exam, this can be, you can be asked for this one. What is the laws of illumination? Kindly write down the statements of the illumination and corresponding proofs. Okay, and mathematical expressions. So it can be such type of question maybe come at the time of exam. So keep it ready. Okay. Then very basic numerical problems are there by implementing that formulas. Okay, so you have that formula. Okay, so you have that formula example. So a lamp giving out 1200 lumen in all directions is suspended 8 meter above of the working plane. Calculate the illuminations or illumines at a point of the working plane is 6 meter away from the foot of the lamp. So it is there 6m. 8m given. So what is that value? You can easily calculate from the Pythagoras theorem. So from the formula directly, that a square root under a square into 6 square. So directly it is coming 10. Luminous intensity, you know that I by I equal to 1200 by 4 pi. Directly you know that formula. Okay. So candle power, you will get that 95.5 candle power. So from the figure you can directly that it is your 10. So cos theta value equal to how much? B by h. That means 8 by 10. So it is 0.8. Okay. So what is your E equal to I? Okay. E equal to this one. Okay. E equal to I cos theta. Okay. Cos theta by r square. Okay. So EB equal to what? EB equal to EA. Okay. I equal to what? In this case EA. Okay, EB equal to EA. Okay, cos theta, here you know like that cos theta by r square. So EA value is 95.5, this one, or I you can say like that into 0.8 by 10 square, or you can write down 0.764 lumen per meter square directly. Another example is there. Okay, so in the corridor lighting, okay, a corridor is lighted by 4 lamps, space is 10 meter apart and suspended at the height of 5 meter above of the center of the floor. Okay, so 4 lamps are there. So define position A, B, C, D, E, F. Okay, so 5 positions are there. From this position, this is 15 meter away. Both the sides, this is 15 meter away. So light 1, 2, 3, 4. 4 lights are there. Okay. So I've seen that illumination at a point C is due to the 4 lamps. Since point C is symmetrically situated between the lamp illuminations at that point, due to L1 and L2. Okay, so L1 and L2, 2 points are there. Illuminations due to L1, how much value? It will be I cos theta 1 whole divided by L1 to C square. Okay, L1 C square, the distance, L1 C square. Okay, basic formula. What is the L1 C square? Root under 5 square plus 15 square. Okay, that is 15.8 meter. Simple as it. Cos theta equal to 5 by now L1 C square. What is L1 C square? L1 C, that is 15.8. 5 by 15.8. Directly we will get that value. Okay, so now what is the value of L1? L1 equal to I. You will get that how much value of I is there. Okay, so it is given 200 candle power. Okay, so it is 200. Sorry. each lamp is given 200, so horizontal. Okay, so you know that total distance is so directly formula you can find out. So it is coming 220 into 5 by 15 points. So this is your cos theta value. Okay, so cos theta value and your how is it 220, that I need to know. Illumination, the point between the midway between C, that is 5 by 1. Okay, maybe some is there. Okay, so now this one is your L1. Okay, now you can go for that L2 also. 200 by 50. Yes, some mistakes are there. Yes, yes. Now for L2, you directly get it from L2C from here. Okay, so L2C from you can calculate from how do you get the L2C. That height will be 5 meter and this is 10 meter. Okay, so this is 10 meter, so it is also 5 meter. So directly you will get it from L2C means root under 5 square plus 5 square. Okay, so 50 means you say like that 50 means 25 into 2. So 25 means 5 root 2. LC2 is coming 5 root 2 and theta 2 equal to 42. Okay, so theta 2 equals to what? Cos theta 2 b by h. Okay, this is b and this is h, 5 by 2, 5 root 2. So 5 by 5 by root 2. Okay, 5 root 2, it is coming root 2. So 1 by root 2. So cos theta 2 is coming 1 by root 2. So 45 degree. And the illumination due to L2, that will be 200. Okay, 200 is there, candle power. Okay, so 200 is there. Okay, so and 5 meter above, so definitely, and this is 50, 200, that candle power is given, and another one is that distance is how much? Distance is 50. Okay, that distance. Okay, and in that case the distance is what? LC1, you know that distance, distance is your this is 15, so it is coming, the distance is coming 15 square plus 5 square. Okay, so that's why this is 250. So LC square, no, this value is actually LC square. Okay, LC square means how much value is it? Okay, so LC square, it is coming that 5 square plus 15 square. 15 square means 225 and 5 square 25. So directly it is 250. Okay, but in the second case, what is the distance? Distance is L2C square. Okay, L2C square means it will be 50. This is 5. This is also 5. So 25 plus 25. So that is 50. Okay, so that's why it is 50. But I think this will be 200. Okay, instead of 220. Okay, so it should be 200. Okay. Okay, that value should be 200. Okay, let me check it, how much it is coming. 200 into 5 by 15.8. Okay, divided by 250. So it should be 200. Okay. That value 220 is written. So please change it. Some printing mistake is there here. Okay. All of you able to understand? That should be 200. Okay. This will be 200. That candle power is given 200. That's why it is 200. Okay. So please change it. You please change it. You please change it to 200, and that answer is correct. Answer is right, but it will be changed to 200. Okay, so update it. Then next in this case, so 200. Okay, the candle power is given L2 into and cos phi 2 is 1 by root 2 and whole divided by 50. So it is coming 2.83 lumen per meter square. So illumination at C due to L1 and L2. Okay, how much it is coming? That 2.83 plus 0.253. Okay, so if you add them, so it is coming 3.08 lumen per meter square. Illuminations at C due to 4 lamps. Okay, so now you can multiply it. Okay, this is for lamp 1 and lamp 2. Lamp 1, lamp 2, both L3 and L4 both are identical like your L1 and L2. So directly you can add it, okay, or multiply it. So 2 into 3.6, so 6.16 lumen per meter square. I hope all of you are able to understand. Okay, if you have any confusion, please let me know. Okay, so are you able to understand?
Yes, sir.
Okay, good, very good. So now we can go for another example. So two lamps are there, A and B. Okay, two lamps are there, A and B, of 200 candela and 400 candela, means candle power. Okay, respectively, are situated 100 meter apart. Okay, so 100 meter apart. Here you can see this C is there. That point L1 and L2, two lamps are there. Okay, so this is 200 candle power and this is 400 candle. Okay, so and this is 10 meter. Okay, the height it's given. Okay, so ground level A is 10 meter above and B is 20 meter above. So B is, this is your B is 20 meter above, A is 10 meter above, B is 20 meters. So given, so theta 1 you can easily find out, and this is 50 m. So root under 50 square plus 10 square, directly we will get that LC L1C. Similarly, we will get find out that L2C as well as theta 1 and theta 2. Both you can find out cos theta 1, cos theta 2. Okay, so that is coming 51 meter L1C. And another thing is that the photometer is placed in at the center of the line joining up to lamppost. Calculate the reading. So here, okay, so photometers are there. When the illumination photometer is placed, okay, at the center point, it will read the value of the combined illumination produced by two lamps. Okay, L1C is how much? Root under 10 square plus 50 square. So 51 meter. So L2C is how much? L2C you can also find out 20 square plus 50 square. 20 square plus 50 square. So it is coming 53.9 meter. Okay, so cos theta 1. Theta 1 you can find out B by H. B is 10, H is that 51. So 10 by 51 and cos theta 2 20 by 53.9. So illumination point C due to lamp L1, directly you know that candle power is given for condition 1, 10 200 into how much angle is it? Okay, 10 by 51, 10 by 51 whole divided by distance. L1C square. L1C is 51 the whole square. Okay, so it is coming 2600. So directly we will find out 0.015 lumen per meter square. Okay, similarly illumination due to L2 you can able to calculate for L2. Okay, L2 equal to how much? That candle power, that is 400. Okay, so what is the cost value? Cos theta 2 20 by this one. So this one is coming is 53.9. Okay, L2C 20 by 53.9 whole divided by 53.9 whole square. So that is coming 2900. So it is 0.051 lumen per meter square. If you add both of them at EC, what is the lumen per meter square? So it is 0.051 0.066 lumen per meter square at the last. Okay, so by that way you are easily find out that very simple numerical problems are there. You can easily find out their illuminance or illuminations at the single point. Okay, now that the third, that laws of illumination, third one. Okay, so shifting of the surface, a perfectly diffuse surface. Okay, perfectly diffusing surface has a luminous intensity 10 candles at an angle 60° at the normal. The area of the candle surface is 100 centimeters. So A is given. Now determine the brightness of the total flux of the radial. The theta shift is there. Okay, so luminous intensity given that B is the define the luminous intensity divided the 10 candle are given. Now projected area has changed A cos theta. A 100. Okay, A is 100 cos into 60°. That is given that 60° has changed. So 50 centimeters square is coming. Now B equal to what? 10 by 50, 10 candles by 50. Now area has changed 100 to 50. So it into 10 to the power minus 4. So all case centimeter square and minus 4s are there. Okay. So semi square. Okay. Then minus 4. So how much that value? So you are converting it to the meter. Okay, so again, if you make centimeter means 100 meter. So centimeter square means 100 square. So if you mean changing them, so it is coming like that. 2 pi into 10 cube lumen per meter square. So total flux radiated. Okay, so that one 2.2 pi 10 to the power cube into 100 into 10 to the minus 4 direct area we are getting from here. So 68.2 lumen. Okay, that simple things are there. Okay, by that way you are getting that one. So I hope this up to this point. Okay, up to this point you can prepare yourself. Okay, for the exam. Okay, so for the next class we'll start from that next section. So different types of source. Okay, and some polar chart or CP distributions, use of polar curves. So these portions are different diffusing reflecting surfaces of the illumination. That portion we will discuss in our next class. Okay, next class means after your exam. So up to this point, okay, up to this point you please prepare yourself for the exam. Okay, so I am asking about your assignment. So Anshuman.
Yes, sir.
Yes, sir. Can you send me the link of that subject?